Okay, so you guys, when I saw you on Tuesday, we got to this at the very end of class. So we were talking about how we have a power function, and the inverse of that will give me a cube root function. So my green right here is my power function. My red is my inverse. That inverse is a new function that we are going to go talk about and do transformations on. So we got those points. So I want to be able to come over here and I want to talk about a few things. So we have this x-intercept, y-intercept, where it's increasing at, end behavior, domain, and range. So we are going to go talk about this and plot in some points. So this is the third root of x. Here's the thing, the third root of a -8. If I come and I plot that in, math to get my third root, I'm going to 4, third root of a -8, what do I get? A 2. So if I want another output that's a whole number, I would need to put in a negative what? 1. And then if I want another output that's a whole number, I would put in like 0 to output a 0. If I want another number to input, that would give me, oops, go to. Well, 1, right? It's going to give me a 1. So I'm coming back over here. So at -8, I get a -2. At -1, I outputted a -1. If I put in a 0, the third root of 0 is 0. If I put in a 1, the third root of 1 is 1. Here's the thing, 8. The third root of 8 is a 2. So here's the thing. I want to make sure I go -2, -1, 0, 1, 2. If I wanted a 3 here, what would I need to input? So here's the thing, 3 times 3 is 9. If I third root of 9 is not 3, but 3 times 3 times 3 is 27. If I put in 27, the third root of a 27 is a 3. So if I wanted an output of a 4, I think back through, right? So I need 4 of something to input, 3 of 4 to get that. So 4 times 4 times 4 is 64. So the reason why we focus on the numbers that we focus on is because these numbers right here that I'm talking about are the ones that I will end up plotting from a -10 to a +10 window. What we have right here. 27's awesome, 27 and 3 is awesome, but we won't ever see it on a thing, or 64. So on the flip side, -27 would give you a -3, and a -64 would give you a -4. So we're going to go plot those points. -8, -2, -1, -1, 0, 0, 1, 1, 8, and 2. So I'm going to curve my one side up, and I'm going to curve my one side down. I'm going to give you 15 seconds to get that. Okay, so let's go talk about stuff that's going on with this. We have a center point, which is right here at that 0, 0. So I have a part that goes up and I have a part that goes down. It happens from that 0, 0. So that 0, 0 is also my x-intercept for this parent function and my y-intercept for this parent function. So then I need to ask myself, does my function ever, so it's an increasing interval, so does it ever decrease? So if I come here, I'm increasing, 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 increasing. So I'm increasing over everything. So whatever x values I put in, I should get those out. So I have a -infinity to a positive infinity, which is my increasing interval. I have up over here in Desmos, I have a few things plotted. We'll get to those in a sec. So this is our inverse. So this is our parent function. I mean our power to the third. It's always increasing, but then my inverse of that is also always what? Increasing. So then let's talk about end behavior. As x goes to the right, so as x goes this way, what do my y values do? They point up and head to a positive infinity. On the left side, we come this way, my y values come and they're pointing down, going to a negative infinity. So then let's talk about domain and range. My x values, I'm going to have x values because I know this. I'm headed to a positive infinity. I'll have everything going to a positive infinity, but I also have everything going to a negative infinity. So my domain's from a negative infinity to a positive infinity. So my y values, if I look at it over here, right? My y values are headed this direction all the way up to a positive infinity, and then my y values are also going all the way down to a negative infinity. So my range is a negative infinity to a positive infinity. Both of those are the same. So here's the thing with that. That means all reals, right? So negative infinity to a positive infinity means all reals, and that's one way to write all reals. Can you give you guys 15 seconds? Turn your page over, or wherever you're at. I think you guys need to go to a new page. We're going to do this, and nope, you're all on one page still. Right, key concept. A cube root function is the inverse of a power cubic function. So what this is saying, right? These are inverses of each other. Okay, domain's all reals. Any x value is going to work on that for us. So this is what we're going to do. Your table in your notes has 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So we're doing transformations on a parent function, which is this right here. So here's the thing. Right here, I'm going to say this. I have a +2 and a -2. How do you think that's going to affect these graphs? I'm hoping you are saying something like going up and it's going down, because the +2 is going to make the graph go up, the -3 is going to make the graph go down. So first thing we got to do is go plot this parent function. So this is now the second time we've plotted it. If I put it in -8, -2, -1, -1, 0, 0, 1, 1, and in your guys' notes you have space for 8 too. I'm going to go plot those. Right, so I have those points plotted, and then I'm going to curve up, and I'm going to curve down, and then I have my parent function plotted. I'm going to give you guys 10 seconds to get caught up. Okay, so our next function we want to talk about is g of x. Right here. So this one, we're going to say that that's going to move it up, what, 2? So I take each one of my parents' points and I move them up 2, 1, 2. That parent point, I'm going to move it up, 1, 2. That parent point, up 2. That point, up 2. And over here I go up, what? 2. So I have from my center, I curve this way, and then I curve, what? This way. So looking at that, my x values stay the same, but my y values are going to shift. So I know I'm going to have this -8, -1, 0, 1, and 8. But at 0, I went up 2. And at 1, it's at a 3. At 8, it was a 4. So 4, 3, 2, 1 at 0. -8 was a 0. Works. Going to give you guys 10 seconds, and then we're going to go finish stuff off. Alrighty, so here we go. This -3 should put us down 3 units, so I'm going to go down 3. 1, 2, 3. I knew it needed to be in a different color. Let's go to red. Right? This point's going to go down 3. 1, 2, what? 3. This point's going to go down 3. 1, 2, what? 3. This point's going to go down 3. 1, 2, what? 3. And then this one, 1, 2, what? So then this side curves up, and this side curves what? Down. So my x values stay the same, but my y values have definitely stuff's happened to them. So at 0, it's a -3. At 1, I have a -2. Over here at 8, it was a -1 is my y values. So for my parent function, it's like I took away 3. -2 minus 3 is a -5. -1 minus 3 is a -4. 0 minus 3 is a -3. All to my y values right there. So if I'm going to come over here, I'm going to show you something in Desmos. Okay, so right here, oops, we're going to get there. So I can move my graph. There's my parent one. I'm moving my graph up or down. It gets moved from that dot that's in the center, that is that 0, 0, right? I'm moving up and down from that. So when I add a term at the end, it's going to move it up or it's going to move it down. Here's the thing. Let's talk about domain and range. In our notes, we know the parent function, my domain's from a negative infinity to a positive, or another way to write that is all reals. So if I look at this, the end behavior stays the same on all three of my functions. So then I'm going to have the same domain and range for all three of my functions because all stuff works. So all I'm going to do is arrow stuff down to match. I'm going to give you guys like 15 seconds.